So, same cuboid shape, same dimensions, but this time we want to find out the angle that is at the corner A of our red right-angled triangle. So we used Pythagoras' theorem before to find out the length A to F, but this time we're using trigonometry to find out what that angle at A is. And so if we think about our right-angled triangle here, we know that this side is 7 centimeters, this side is 3 centimeters, and this side is the square root of 40 centimeters. And so if we're thinking about this angle A, then we can label using the trigonometry labels. So opposite of the angle A is 3 centimeters here. So our O, our opposite, is equal to 3 centimeters. And our longest side, opposite the right angle, is always the hypotenuse. So our hypotenuse H equals 7 centimeters. And if we were wanting to label it fully, the adjacent side to the angle that we're interested in, A, is equal to the square root of 40 centimeters. So generally it's easier to use simpler numbers, so I'll choose the hypotenuse and the opposite to figure this one out. So if we look at our SOHCAHTOA to figure out which function we're going to be using for that, if we're talking about using the hypotenuse and the opposite, then you see that it is going to be sine that we're going to be using. So what that means is that sine of the angle, so in this case A, is equal to the opposite, which is 3, divided by the hypotenuse, which is 7. And so to find out A on its own, I use the inverse sine function, which will cancel out the sine function and just leave me with my A. But what I do to one side of an equation, I have to do to the other. So I do the inverse sine of the 3 over 7. And so if I type that into my calculator, usually there's a shift button, and then I press the sine button, and you'll see that it's got that -1 symbol on it to show that you're using the inverse function. If I press my fraction button, I can put my 3 over my 7, close the brackets, press equal. You see that in degrees, this tells me the angle is 25 point, and I'll round this to 1 decimal place. So 25.4 degrees to 1 decimal place. Now just to show that you could have used another trigonometric function if you wanted. So we could have used also cos, because we know all 3 here. You won't always know all 3, but in this case we know all 3 lengths of the sides here. So if I wanted to use cos, that would be that cos of the angle A was equal to the adjacent, which is the square root of 40, divided by the hypotenuse, which is 7. And so if I do the inverse, if I clear that, I do the inverse function of cos, and I put in then inside square root of 40 all over 7. You can see that this again gives me 25.4 to 1 decimal place. It's 25.4 degrees, 1 decimal place. And then maybe you can check for yourself, how could I have used the tan function to find out what the angle is for here? And then the other question would be, what is the angle F? So you could use trigonometry for that, or if you remember that the internal angles inside a triangle will equal 180 degrees. So if I write that down, the angle A degrees plus F degrees plus the right angle, which is 90 degrees, for a triangle will equal 180 degrees.